那也没干。二胡
Hello，张老师。No, tell me song. Hello. Hello. That's not a ding ding. Hello. I don't know. Hello. Chapter 5, 我都没有读。还有这些没读。
对。Hurry.
Hello.
Oh, you can hear me? That's good. There will be somebody else. There will be several people today.
Okay.
Oh, you know everybody. Skyla, you know Skyla actually, right? Remember you sit with Skyla before?
Oh, really?
Yeah. So you know him. So you add somebody else. I think William. You also know William, right?
William.
Yeah.
What? William who?
William Wang. Hi, Skyla. There is also Andy. You know. Yeah, this chapter actually the exercise you just did it. They didn't really do it, but they learned something like a few. Let me see. Few very far already. They learned chapter 14, 15. Chapter 14 already.
Chapter 4?
But right now, today we are doing chapter 5. The exercise actually, I think you said you did probably a little bit boring to you today because you did that exercise already.
Yeah, I did some of them.
Oh, okay, that's good.
Yeah. I never used LaTeX before, so.
Yeah, the first time, that's okay. Hello, William. William is here. Hi. Hi, William.
Yes.
Oh, okay. Henry is here today. You know Henry, actually. You know Skyla.
Yeah.
Can you hear me?
Yeah.
So Henry is here too. You know Henry, right?
Okay.
You know Henry? You remember you sit with Henry before?
Future lesson, right?
Actually, this chapter, the exercise, Henry already did it. Henry had been with me for the MC more, I think over 1 year, right? Right, Henry?
Yeah, probably.
Yeah, over 1 year. Anyway, Frank, the William and Skylar been more than 2 years already, right?
Yes.
Yeah,
Almost 2 years.
But for this chapter, we actually Henry just did that chapter. For this book, for the book 2, we William and Skylar actually they learn the chapter 6 to 7, then to 14 first. Then we come back and learn the several chapters here.
Oh, okay.
So is the right time today actually. So both everybody is going. So there's also Andy. You know Andy, right? No Andy, right? So we can see each other actually. Let's see. All right. Okay. So you can. Today we start with the exercise in chapter 5 first. And we share mine. Actually, I can share my screen in a minute. Give me a second. Okay, chapter 5. Everybody, you guys doing the homework? Start with William. Did you do the homework?
Yes.
Have any questions?
80 and 81.
Only 80 and 81?
And then I think that's it.
Okay. Skylar, how are you?
I did them.
Huh? What?
I did them.
So everything?
Yeah. 80 and 81.
Only 80, 81?
Yeah, I think that's it, right?
Okay. Okay, well, give me a second. There's some problem with the file. It's incorrupted or something. There we go. There you go. Andy, did you do anything?
Yeah.
Okay, what problem do you have?
80 to 83.
Okay. All right. 83. Hurry, you did that everything already, right? Did you have any? Maybe it's a little boring to you. Did you have any problem? Any question with that?
I don't remember if we went over it.
Okay. Oh, yeah, we can go over with something is going on with my computer. Wait a second. What happened? Okay, there you go. There you go. Okay, wait a second. There you go. Okay, so Can you see anything? You cannot see anything yet, right? There is a line. Now you're okay. Okay, let's go through everyone. So the start with 72. That should be easy. Okay, just answer that would be enough. So let's start with William. What do you have this one? William. What?
X minus 4 squared over 16 minus y minus 1 squared over 36 equals 1.
Okay. Y minus what?
I said y minus 1.
Okay. 1. 1.
Yes.
Okay. Over 9.
Over 36.
There is it. The 1. Okay. The same thing, everybody?
No.
No.
I got something different.
Okay, what do you have?
I have x minus 4 squared over 4 minus y minus 1 squared over 9 equals 1.
I agree.
Yeah, maybe I should try using this thing. Okay, you should have this. I was testing on that thing. Okay, now it's working. Okay, let's start with the game. So I might have to write that thing. So for instance, so William has the minus 4 squared over what? 16.
Yes.
Then minus
Minus
what?
y minus 1 over 36.
So Skylar has a different, right? Skylar, what do you have? You have x minus 4 squared, right? Skylar. You're saying over what? Skylar. Skylar? What is Skylar has? William, do you hear? Something wrong with Skylar.
I think 4 for x and 9 for y.
But Skylar left the meeting. Skylar has something wrong with it. Skylar lost the connection. Wait a second. Skylar is coming. Okay. He lost the connection. So what's something wrong with it? So Skylar, what do you have?
It's x minus 4 over 4.
Over
And
4.
It's over 4 and over 9.
Okay, okay. Okay. Andy, what do you have?
I have the same thing as Skylar.
Okay. So Henry, do you still remember what you did? What you did with it?
Yeah, I wrote it down. I got the same thing.
Oh, the second one?
Yeah.
So must be the second one. What happened to you, William? Let's see. So on the page 45 of the book, say if the center is
It said it was the same ratio, but when I was calculating to make sure the proportions were right, I must have did it wrong.
yeah. Let's see. So if the equation is x minus h squared over s squared minus y minus k squared equal 1, then asymptote is y minus k equal b over a over x minus h, right? So you just compare everything. So you get k equal 1, h equal 4, b over a equals 3 over 2. B over a squared is 3 over 2, then b equals something, 3ta equals 2t, then the equation is something like that, right? So you might be right. So what do you have? You might be right. 1636. Yeah, might be right. But you have to have the 6-1 to be on the curve. So 6-1 the curve, see, you immediately see t equal 1. So it must be. So the majority are correct now. Okay, the second one, Skylar. Second one, talking about the second one. Yeah, everything is very, very easy. So what do you have the second one, Skylar? Skylar get disconnected again. Skylar.
A equals negative 1a, b equals 1, c equals 0.
Okay, so ABC equals to, huh?
Oh, negative 1a, 1, and 0.
0?
So ABC equals 0, right?
Yes,
Okay.
yes, c equals 0.
All right. So the answer is 0. The answer is 0. Skylar has 0. So what do you have? Andy, what do you have?
I have 48.
Cool. 48. So do we have anything?
I got 324.
So, William.
Negative 20?
Okay. Wow. Okay. All right. So 3 of them must be right. So let's see who can be right. Okay. So, all right. I said that one. Say maybe William saying that. That okay. Anyway, the parabola has vertex 4, 2. If 2, 0 is on the parabola, find ABC. So you first off you using what to find the vertex? Huh?
Could you repeat it?
Using what thing to find the vertex?
Vertex form?
You using what to find it?
You already have it. Yeah.
No, I can give you the general form. How do you find it? So that's the way you find it. You're using something called complete square. Okay, we're talking about this 3. So you're saying that is b over a x plus c. Then using that thing called a and x square plus b over a x plus what?
B squared over 2a? Or b over 2a squared?
Yeah, a minus b over 2a squared. Okay? Then equals to a then x plus b over 2a. Then square, then plus b minus b squared y squared. Right? So this is a vertex. Vertex is b with 2a, then c minus. Sorry, hard to see it. That's the vertex. So basically, they tell you that one equals to 4, right? So well, that one equals to what? To 2, right? So then there is another condition. Half 2, 0 means A then times 4 times B times 2 must equal 0. So you have 3 equations. So that one, then have that one. They have 3 equations, 3 variables. So okay, you solve it now to see what you have. Did you do that one?
No, I think it's easier just to like write it in vertex form first and then just expand it out. If you can find the
Yeah, that works too. Yeah. So that's actually the excellent idea. So you can just write as the 4, 2 as the vertex, then expand it. Then you actually you should get the similar thing actually. Yeah, that one is pretty better actually.
Yeah, that's the way I did it.
Okay. So then the result is not. So solve now. Let's just solve together to see what happens. Okay. So we have B equals to minus 8A. Okay. Right.
Yeah.
Then you have C equals to minus 2B minus 4A. So minus 2B, which is 16A, minus 4A, which is 12A. Right? So that's the relation between C and B. Then you have C, which is 12A, minus B squared over 4A squared, which is 64 divided by 16. 16, that's all. Right? Yes, equals to.
Yeah.
Okay, so you get A equals to what? Huh? 18 divided by 12,
Yeah.
which is 3 over 2. Maybe I did it wrong. I don't know. So you get B equals to minus 8, then get 12, right? C equals 12A, which is 18. Wow, that's a big number. So ABC equals to, okay, whatever it is. Is that right now? Three times 4 times. What? I think we did something wrong. I did that different.
Yeah, I think the calculation for A is a bit off.
Okay, let's see what I did.
Wait,
I
is this
did.
supposed to be negative B squared and 4 squared?
Oh, yeah, we have a 4A here. This is wrong.
Yeah. Yeah, it's, yeah.
There's no A here. But no A, no square here, okay?
Okay.
Okay, then no square here, then means here is a little bit different. 12A minus B squared, which is 344. 36. A. Okay, 36A. This is different. This is different from what I did. Minus 24 minus 1 over 12. Is that right?
Yes, but that's not what I got.
So A equals that. Anyway. B equals to
2/3.
B equals to -1. Yeah, we did something wrong. I think A, B, C then equals to, it's a fraction. Let's see what I did. So we have this. So far is good. Then you get B over 2A. Oh, you get next. Yeah, that's still right. So get that one equals to 2. 4A plus 2B equals to 3. Why is it more a bit?
Oh yeah, we forgot to make it negative because it's like the x minus 4 squared. So then the x coordinate will be 4.
So what I did is right? Did you say?
Yeah, the power point.
Sorry, say that again, Harry.
The power point, because when you use vertex form and it's like in parentheses x minus 4 squared, the 4 will be the x coordinate, so it has to be negative.
Then B over 2A, negative 4.
Yeah.
Yes. Okay, here's what I got. We just did something wrong over there. I think I got correct. A, B, C is 12. So we just did something wrong with here and go. So what's wrong with it? Let's do it again. So B over 2A. B equal minus A, and 4A plus 2B plus 0. Then 4AC minus O. C minus, okay. That should be right. C minus, I think we missed something there. C minus D squared over 4A equals to 2. So we missed it. Okay, just solve that one. Why you cannot get, so B equal minus 8A and C equals minus 4A minus 2B. 2B will be 18A will be 12A. Okay, this time is right now. So 12A minus B squared, 16A. A equal 1/2. Okay, there you go. So B equals to 4. B equals to minus 6. All right. All right. Pretty hard, pretty easy to get wrong. Good? So let's see what you have. So 048, 300, minus 20. Okay, none of them is correct. I even I did wrong as the first time. Okay. Have to make that right. Actually, that one and back to Andy's first.
I got 16.
Huh?
I got
16?
16.
Okay.
I agree.
Agree?
Same.
Everybody agree?
Yeah.
Yes.
Okay, that's excellent. I think everybody agree should be right. Should be right. Let's okay. Now go to the next one. Continue back, start at the point x, y. It works in a straight line to the point -5 y square 5 0, then a straight line square 5 0, then straight line to initial point. How far the spark have worked? Henry, do you still have the answer?
I wrote 6 plus 2 root 5.
Same.
Yeah, same answer.
6 plus what? 2 square 5.
Yes.
Yeah.
For same thing
Yeah.
should be good.
Yeah.
For same thing should be good. Yeah. Okay, you using the focus. Oops, it's not that one. What? We're going too quick. Okay, this one. Okay, next one. If two intersecting lines intersect the hyperbola, and neither line is tangent to the hyperbola, and what is the possible numbers of the length where the line can intersect the hyperbola? William.
1 through 4.
Huh?
1 through 4.
1, 2, 4. 1, 2, 3, 4, right?
Yeah. Yes.
Okay, so everybody agree?
Yep.
Then we move to the next. Okay, 1, 2, 3, 4. So one is has to make the same two lines parallel to the exponent, right? Then we test somewhere. Okay. Point A, B are selected on the graph of that so that triangle is equilateral, where O is already find the triangle ABO. The line. I think this is Skylar. We have Skylar.
4 square 3.
4 square 3.
Agree.
Yeah. Same answer.
Same answer, everybody?
Yeah.
Okay, cool. Andy, you have same answer?
Yeah.
That's excellent. Okay. 4 square 3. Parabolic arc has span of 24 feet. Its height is 18 feet. What is the height? This turn? Okay, end it, alright.
Oh wait, for this, what was the span?
It's the y, it's width. Just like I mean, drawing the picture for you.
Oh.
So you have something like this, right? Span is this span. Okay? You got it? Span. Okay, if you didn't do it, you cannot finish now. Who has the answer?
I do. I don't have the next one, so.
Okay.
I have it.
I got 81 over 4.
Skylar has 8.4.
I have 32.4.
30 how many?
32.4.
Oh, 32.4. So it's not 82. So what is that? 32.4. Who has who? So this is definitely not right. So what is this?
Which one are we on?
76.
76.
I have 16 squared over 5.
81 over 4 is my answer.
What's your answer, Henry?
81 over 4.
Oh, this H1 over 4. Oh, okay. Okay, I'm sorry. Yeah. Okay, so
My answer is 162 over 5.
yours?
Yeah.
Same thing as
That's the same as mine. Yeah.
Okay, let's look at quickly again to see the problem is. So find 24. So 8 point then get 18. What is the height? So basically, if you have met the coordinate like this. So we're saying this is 24. So from 8 from here, then fit something here. So this point is like say 18, right? So that's it. So you have then basically calculate the height here. So you assume Z1 equal Y equals to something X squared. That's all. Right? So huh?
Yeah.
So this one you pass the point X 12, 0. So X equals 12, Y equal 0. So you have zero. Then another equation is X equal 8. 0, right? Just solve the equation, that's all. What do you got? Solve it again. I'm sorry. No, plus B equal 18. Huh? You just solve that equation, that's all. Right?
Yeah.
You just need to solve B now, right?
Only B.
Yeah, only B. So
I got 81 over 2.
yeah, that would be H1 over 2, 2.5. It should be 1, I think it should be 144 then. Then you also put together. Okay, let's put together. I actually have it here already. It's not. So that's actually is a typo. It's y equal minus 940 x. Okay, over plus 152 over 5. So the B is the answer. B is what we're looking for. You get it right?
Yeah.
All right. Andy, are you there?
Yeah. I understand.
You get it right now?
Yeah. I understand the problem.
Henry, did you get it right? Rewrite? You get it right now? Huh?
No. I understand too.
the next one. I think I'm hungry. Henry?
I have a check mark. We did it in class.
Huh?
We did
I'm
this
sorry.
in class.
We did that in class? Yeah. You still remember it? What do we have? Oh, yeah, we did it in class. Yeah, that's right. Okay, so William, what do you have? That's for answer.
3/4.
3/4. Okay, let me write down your 3/4. What do you have, Skylar?
I have 3/4.
Oh, and the same thing?
Yeah.
Sure. Okay, so actually, whatever you have, it's okay. The very important about this one is the concept saying you have a circle. Have a circle somewhere. They ask you about saying this is when y equal mx plus 1. So the circle is, what the circle is?
It's an ellipsis.
Yeah, sorry, no, not circle. It's ellipse. Ellipse. So, yeah. Ellipse. So for that ellipse, whatever it is, so let's just join the real one actually. So join the real one. So the ellipse is x has 2, y has x has 1, y has 1/2. That's what it is. So x equals 0, y equals 1. So it's past. Oh, it's past here actually. Here. Oh. So that tangent could be like this. Could be a tangent like this.
Which is why they asked you for m².
Yeah, it's y equal. That's exactly right. One could be positive, one could be negative. So what you have to do is say you plug in y, then you get x² plus 4 and mx plus 1². So that equation can only have one solution. Okay, tangent means only one solution. So when when this line is tangent, okay, tangent, then that one you're going to have one solution. So which means the dirt has to be 0. The dirt has to be 0. So you expand it, whatever it is, the coefficient of x and square and minus 4 and minus blah blah has to be 0. Then you solve the m². So let's see what it is. So you have x² plus 4 then m square x square plus 2mx plus 1 equal 1, right? So you have 4m squared, so 4m squared. Anyway, everybody already get it. So we will have more problem about things like that. Only one x. Okay? Yeah. So you have this one, then you have the discriminant got to be 0. And you solve that. Solve it. Whatever it is, then you solve it. Okay. That one's a little, what do you have, William?
This is the last one, but
Let's move to that one should be straightforward, okay? So just multiply, just multiplying, then get r cosine equal to 2 and plus cosine square. That's then multiply r square again. Do you have a question about this? Or we
No.
skip to next now. A circle has a center. Who has 改了
I have 11.
11.
Same.
Yeah.
Alright. Do you still remember? It's been a while for you actually.
I don't know.
Okay. Let's see the solution. I have the solution actually. So basically P F1 F2, because this is a circle, so the P F1 F2 is Pythagorean. Is a right triangle. So you have to the K is using Pythagorean theorem. So the PF1 plus PF2 is the major axis. So PF1 plus PF2 equals 15. So you have the PF1 times PF2 is double of the area of PF1, PF2 because the right triangle. So you have PF1 plus PF2 equals 15, and PF1 times PF2 equals 52. Then you square the first one, then you get PF1 squared plus PF2 squared equals 121. So the answer is 11. Clear?
Yeah.
All right.
Good.
Okay. Next one. Next one is something we're talking about and don't know how to do.
I'm a little confused by like how they just worded this.
Okay. So what if this is, then you have a square. Right? So A, B, C, D. Then you have any point like P is here. Then you have the P, and P. Okay? So P is here. So PA, then PD, then PC, then PD. So so PA, PB. So let's just make the coordinate system. We assume A 1 0 0 and B 1 0, C 1 1, B is 1 1. Right? Then P is XY, okay? Then PA, which is so PA square plus PB square equal PC square. That's what it is, right? Let's see. P to ABC, yeah, UVW, then that's it. So PA square, you just calculate is X squared plus Y squared. Right?
Yeah.
PB square is X minus 1 square plus Y square equals to PC square, which equals to X minus 1 square plus Y minus 1 square, right? So you cancel the minus 1 square. We get x squared plus y squared minus y squared plus y squared, then plus 2y minus 1 equals 0. Okay? So the trace of which is x squared plus y plus 1 squared equals to 2. So what is it? What is it? Huh? What is this? Huh?
A circle?
A circle, yeah. A circle. The circle center is here, right? So the diameter is
Diameter is 2 square root 2?
square root 2. Oh, sorry, diameter. Your radius is square root 2, right? Yeah. Right?
Yeah.
So which P is farthest to D? So here, this point. This point is the farthest, right? So what is the distance? What is the answer? So here is
2
1.
plus square root.
Huh?
2 plus square root 2.
2 plus square root 2, okay? Question?
No.
Huh?
No.
No.
Oh,
All right. I think I did the same thing here. That's what it is. Huh? It's obviously 2 square 2, huh? What? Oh, PD square is that. Wait. What did I do? PD square. PD. Obviously that one. What did I have? So that's actually square root 2. This can be still can get up. Let's see what it is. The square root of 2, then square root 2, then 2 square root of 2 plus 3 equals square root of 2, then plus. Okay, this value actually equals 2 plus square root of 2. You see it? That's very funny. Okay, calculate different way. So I calculate. So I have it square root of 4 square root of 2 plus 6. What we have is 2 plus square root of 2, right?
Yeah.
They're the same thing? Because square root of 2 and 2 square root of 2 plus 3, okay? So it's square root of 2 and square root of 2 square root of 2 plus 3. So 3 plus square root 2 is 1 plus square root square, so it's square root 2 plus 1. So it's 2 square root. Okay. Same thing. Okay. What I did is using the formula. Okay. Then figure out for which y the value will take. The most negative value is that one. Is that one. Okay. So most negative value is that one. So same thing here. Okay. Good. Now we come to 81. 81 is everybody need to do the answer, right? And then you just to join with the measure and the sorry, it's misspelled. And 10, 8. Using one focus at center, circle is joint that is tangent to the ellipsis with no part of the circle being outside the computed radius of the circle. Actually, this one, when I tried to do it, actually I originally thought the circle will, so this is this. I thought the circle could be like something like that. Then actually, let's go in. So A is 5. Here is 5, 0. So B is 4. Here is 0, 4. So you see the focus, which is 3, 0. Right? So the circle actually, so here is the conclusion. Circle actually is that circle. So the center is here, just the tangent. This is where you need to find where the tangent is. So actually I'm trying so how do we prove it? That's the thing, right? How do you prove this is the solution? So you want to issue the answer that just directly. So that will be the final thing with it. Just a coincidence for this one. And usually, if the center is not focused, it will not be that case. So how do you do it? The circle we guess is actually x minus 3 squared plus y squared equals 4. How do we prove it? We prove the tangent must be 5, 0. Then you want to prove any point UV. Any point UV on here. Any point. So it has the distance from UV to that point. So UV to that point, 3, 0. The distance is U minus 3 squared. Then plus V squared. Must be at least to be 2. So we know that U squared by 5 squared plus V squared by 4 squared equals to 1. So we can say this is equal to U minus 3 squared plus V squared, which is 1 minus 5 squared over 4 squared, and times U squared. So which equals to U squared minus 6U plus 9. Is that right?
Yeah.
Plus 1 minus 4 squared over 5 squared U squared, which is 3 squared over 5 squared U squared minus 6U plus 9. Something weird here.
Doesn't it have to be, don't you have to times 4 squared to the 1 too?
Exactly. Oh, V squared equals 4 squared. So this is the 4 squared, okay? Not 1, right?
Yeah.
Okay. This is a 16, right? So plus 25, okay? Right? So that will be 3 over 5u minus 5 squared. Okay. So the u is x coordinate. The more farthest u is that one. So cannot be more than 5. So that one will be at least will be 5. So maximum you then give that one. So 3 minus 5 squared, which is 2 squared. So at least you see that one. So if u is less than 5, then this value becomes bigger and bigger. Think about u to be negative 5, then one will become 8 squared. So u is 0, then it becomes negative 5 squared. So to make this value to be smallest, to be minimum, you have to take 5. So 3 minus 5 squared. Right? Get it? Probably not.
Yeah.
Probably not. U less than 5. 3 over 5 u less than 3. Everything, so that one is good. At least, so 3 over 5 u minus 5 will be at least 5, 2 squared. So at least 2 squared. So every point has more than that point, so which means the tangent must be that one. Okay? The tangent must be that one. So that's the answer. The answer is that circle. Okay? So the answer is 2. Where is it? What doesn't show now? Here we go. So this circle actually is this. So the question about it, the radius of the circle is 2. Okay.
Okay.
Actually, the next slide is not right. Okay. The next slide is something extra. I don't know where they got. Okay, next one is easy. Okay. So the last one, let's say, Henry, do you have an answer for this one still?
I didn't get it. It was too hard.
Who else?
Well,
Do you have?
1/2.
William has 1/2.
I have 2.
Skylar has 2.
Wait. Never mind. Wrong one. I have 1/2 also.
Oh, that's cool. Okay. So the thing is, you have y equal x squared, like this. Okay. So you saying there is a circle around the inner. So here's center. So here's the tangent. So you want to calculate the difference between this, right? So this is a y equal x squared. This is our most familiar one, okay? So you assume this circle is x squared plus y minus b squared equal r squared. So if this point is x0, y equal b, okay? The center is 0, b. So those two, the tangent, you only have the tangent, then you plug in, you get y plus y minus b square plus r squared. So that need to be tangent, you only have one y with it. So only have one y with it. So that's and whatever the solution is. So that is y squared plus y minus 2b y plus b squared equal r squared equal to 0. So when this quadratic equation has like only one solution, in which situation? Discriminant equals 0, okay? Right?
Yeah.
Okay, so case 1, so that equal greater than 0, it has two solutions. Right? So case 2, that equals 0, has one solution. What is the solution? Do you still remember?
1/2?
No, for this quadratic equation, we just did it. The complete square. Okay?
Okay.
Right? So this is the case. We want delta equal to 0, and then also we know the solution will be that, right? You still remember this? Just the complete square.
Okay.
Huh? Complete square. Let me compute again. So it's a, then x plus b over 2a, then square, plus, and we just did something wrong there. So, oops, I don't mean that. So, that actually this is delta. This is the minus, sorry, it should be a minus. Equal, yeah, 0. So, delta equals 0, x equal minus b over 2a, okay? Got it? That good?
Yeah.
Yeah.
All right. Huh. Why can I go back? That one. So this equation. So we don't really want to calculate. We don't need to calculate that delta. We only need the solution. The solution is y equal minus b, which is 2b minus 1, divided by 2a, which is 2. Right? But how do you get the 1/2? Yeah, here, so this is 1/2. B minus is y is 1/2. So that's it. You don't need to calculate the delta. This is pretty simple, that one. All right. Okay.
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 Okay. That's good. Does anybody still remember the this solution? You can take one more look if you're still confused. Well, who's still confused? Nobody confused. Okay, in this year, 2014, MC12 has one parabola problem. Who remember it? Oh, probably William remember it.
I don't remember.
I don't know. Andy remember it.
Oh, no, not really.
Okay, this is the original question. Saying the parabola P has the focus 0, 0, and goes through 4, 3, and minus 4, minus 1. For how many integer x, y belongs to P such that 4x plus 3y? This is probably the last question in the MC12 in this year.
Something like that.
Exactly like that. Okay. So with the knowledge that we learn, actually that's actually actually I explained that one to Henry already, right, Henry?
Yeah, I remember very clearly. Well, not very clearly, but.
Yeah, I explained to you already. So unfortunately, I didn't get enough time to write the solution in the slide. So so I can explain here. Okay. So if you have that thing to be that thing. So 3, 4, 3, 4, 4, 3. What's this? 4, 3, right? 1, 2, 3, 4. This is the 1 point. There is an point here. So focus is here. So the curve will look like I'm sorry, it doesn't look like didn't really join very well. It's very anyway. So the thing is, if you join connect this line, then you connect the perpendicular. Yes.
It's not perpendicular. It's just reflected across the the x-axis. I mean y-axis.
Oh, here we go. Okay. So here is the 4, 3. Here's the minus 4. So let's say rotate the axis by theta. So theta is 30 sine tangent theta equals to 3 or 4. Or maybe you call tangent theta. Yeah, anyway, same thing, okay? So we are good with that, I believe. Right?
Yeah.
Then that curve will become like that now. So what is that part? What is this part?
5, 0, minus 5, 0.
How long is this?
5.
Huh?
5.
5.
5. So it will be 5, 0 minus 5, 0. So the curve will look like okay. So what is the equation for this? Quickly. Okay, I give you a second. What is the equation for this? Everybody's saying, right? Okay, who is anybody get the equation for that one? Okay, you have focus 0, 0. Then that one pass 5, 0, minus 5, 0, open up. Hmm. What is it? Open up, focus 0, 0, plus 5, 0, plus negative 5, 0. Hmm. Okay, this should be very easy. All right. That's it. Y square equal x square, y equal x square plus something. That's all. You only need to figure out something. Hmm.
So B is negative 25.
So William is saying B is negative 25. Okay. Anybody agree with it?
Yes.
Yeah.
Okay, this actually is y prime, x prime, right? Y prime equal x prime square minus 25, right?
Yeah.
Yes.
Okay. Also here we have x prime equal x cosine theta. How many is the cosine theta?
What?
Cosine theta equal what?
3/5.
3/5?
Cosine theta?
3/5.
Yeah, 3/5.
Cosine theta is 3/5, are you sure?
4/5.
Yes, 4, yeah. Yeah.
So sin theta equals 3 over 5, okay? So we get x prime equal,
Sin theta is 4 over 5.
yeah, sin theta equals 3 over 5, yeah. So we get x prime equals that, y prime equals that, then that. Okay, let's remember it. So we get x prime equal, you still remember? All 5x plus 3y 5, y prime equal negative 3 over x 5 plus 4y 5. Then y prime equal to x prime squared minus 25, right? Okay.
Yeah.
Then we put it back. We get 4x plus 3y actually in the y prime first. So we get 4y minus 3x 5 minus 5. Okay, you should copy everything because I didn't really get time to really write down that thing. So equals x prime, which is 4x plus 3y 5 squared minus 25. Okay. So the first thing is there are a lot of a little bit of number series. So first of all, we can know that 4x plus 3y must be divisible by 5. Have we learned that simple? So which means the modular simple. Did we learn that?
Not really.
Oh, ready? Ready? Which means the modular 5. We did it?
Wait, what?
So modular 5. Which means the 4x and the 3y is a multiple of 5. That's all. Okay?
Okay.
Because you multiply by 5, then this term is the integer, then this term is the integer, then 4x plus 3y must be integer, okay? Get it?
Yeah.
So you have 4x plus 3y will be equal to 5u. Right? Then plug into it, then you have 4y minus 3x, then divided by 5, going to be u squared minus 25. This is 25u squared. Oh, u squared. Okay. U squared minus 25, which means 4y minus 3x is going to be divisible by 5. So 4y minus 3x equals 5 will be. Right? So which means 5v, which is v equals to, I think I did something wrong. Did we do something wrong? Hmm? y prime equal that. Oh. No, we didn't do right, guys. No, we didn't do right. I'm sorry. Let's see again here. Here we didn't really calculate y squared. I think we calculate this equation wrong actually. This equation is not that equation. So we should that one is not right, by the way. So y squared, because we will miss the full. We missed the coefficient actually. So we didn't really calculate this part. You see? What is that part? How long is this? So we should solve that original equation. So y prime equal 4a in x prime square. Let's doing one more time, only with this. We did it the wrong way then. So you have equation like this, 5 zeros minus 5 0. So in box, this is 0, 0 is box. So what is this equation? You can just assume that equation to be y equal 1 over 4a x squared plus b. We're missing the 4a, right? So you have, here you have something here. Then this point has same distance to here. My joint is not that good. So we don't really know. Here is A. This line is A. This line is A, right?
Yeah.
So A plus A actually equals to 5. So that's what it is, right? So that one will be 10 x squared. 10? Yes, plus B. Now it's OB. So for 5, 0, then we got 5, 0, 1 over 10, then 25 plus B equals 0. B. So you give me back already. Okay, there is what it is. All right. This is the directrix. This is the focus. You have to use in the definition, okay? The parabola is all the points has the same distance to the focus and the same distance to the directrix. Confused? 改了
Yeah.
Confused?
No, not really.
Little?
No, not really.
Henry?
No.
Huh? Okay.
No, I'm okay.
Okay, Andy.
Yeah, I'm okay.
Okay, this is using definition. So we are using wrong. So the okay, now back again. Now back again. That one actually is remember what it is? Yes, forgotten already. 1 over 10 squared minus 5 over 2. And this one is 1 over 10 squared over 10x squared minus over 2. Yeah. Okay. This is that. Then you get that, then minus that, then equals that. Then you get 1 over 10 here, then minus okay. We still, okay, we multiply 10. Okay, remember that one, okay? Let me write down now. So 4y minus 3x divided by 5 equals 1 over 10. 4x plus 3y minus 5 over 2. It's too small, huh? Too bigger. So you have 4y minus 3x divided by 5 equals 1 over 10. Then 4x plus 3y divided by 5 squared minus 5 over 2. So multiplying 10, you get 2 times 4y minus 3x equals to 4x plus 3y divided by 5 squared minus what? 25, right?
Yeah.
Yeah.
So we get 4x plus 3y equal 5u, right? Everything is the integer. We're talking about x, y is the integer. So 4x plus y must be divided by 5u. There is a magic thing here. Let's go in the next statement. Okay. If 4x plus 3y is divisible by 5, then 4y minus 3x are also divisible by 5. This probably need to change it to you. Okay? So why? Because you have 4, then 4x plus 3y, and this is 16x, then let's go in 4. Okay, cancel which one? Cancel y. And minus 3, then 4y minus 3x, which equals to 25x squared. Right? So if 5 divide 4x plus 3y. Then you increase 5 divided 4y minus 3x. Okay? Okay. This statement is a little bit new to you. You see? Okay. Now back to the previous one. So we get 4y minus 3x equals to 5v. So we get 2 equals 2. Okay, 2 times 5 v equals u squared minus 25, right? So you get, again, you get 5 also, I divide u again, you get u equals 5w. You get 10v equal 25w again. 25w square minus 25. So you divide by 5, you get 2v equals 5w square minus 5. You get v is 5t again. You get 2t equals w minus 1. Okay, so you get w equals 2t plus 1. So the original question asked you about, probably you already forgot, asked about how many points 4x plus 3y is going to less than 1,000. How many? Then you have 4x equals to 5u, then u equals to 5w. So 4x plus 3y equals 25w. It's essentially 25w less than 1,000. How many of it? 25w is w less than 40. So, but w has to be odd. That's all about. The w is odd and the w less than. So totally how many? So w is going to be equals to minus 39 minus 37 to 37, 39. Okay, that's all the solutions. So the answer is 40. Totally you have 40 of them. All right. That's enough for the question. Actually, I have another question. If you take the notes, you should be able to see the solution. There are a bunch of number series here, saying 4x plus, so that is number series, again number series, a little number series, and even here still number series. But the w has to be odd. The question? All right. Now we go back to the singularity. 9:30, but we can still continue 10 to 20 minutes or whatever. Then have chapter 6, polynomial. Here we go. Polynomial. Okay, we will cover the probability. William?
Yeah.
Right?
Yeah.
Okay with the parabola.
Yeah.
Now we review the polynomial. Henry, are you okay?
What?
Are you okay with the problem with the parabola? Did you guys take the note with the solution on that problem? That problem is pretty sneaky, using a lot of things.
Yeah.
Okay. Okay. The basic polynomial is like this. Okay. So fx equal blah blah blah. Where you see it a lot. So to the polynomial just behave like the integer. You can do multiplication, can do division, can do addition, can do subtraction, just like a number. Also, that's very important thing is called remainder formula. If you have fx gx, then you can always write as fx divided by gx has a quotient, it has a remainder. This is just like exactly like saying for example, 10 divided by 3 equal 3, and remainder is 1. Okay? The thing is, we have here is this 1 is going to be less than 3. So here is f equals g plus r, then degree. Degree is the measure of that thing. So we all learned that thing already. I just do very quick review. If you feel like saying you don't remember anymore, let me know whether you explain to you, okay? So the thing called fundamental theorem of the algebra is saying every polynomial has at least one root. So the same statement saying every polynomial has exactly, if you have nth polynomial, has exactly n root. So nth polynomial has exactly n root. That's about same thing, okay? So we're very experienced with it. So this is something did by Gauss. Gauss, he was 22 years old. He did it. 1979. Okay. So also talk about the rational root. If you have something like fx equal nx plus xn plus blah blah plus a0, assume a0 are all integers. If it is a fraction, will be different. Fraction you cannot get the integer. Cannot be like irrational number, like square root 2 or something or pi. It's not. So we're talking about the rational solution of that fx or rational root, whatever you call it. So zero root solution is kind of the same thing. That rational root can be written as p over q. Then p must divide the a0, then q must divide the an. So q divides the first coefficient, then p divides the last coefficient. Do you still remember? I guess so. So, like this equation, you can only have the rational root like plus minus 1 plus minus 2 plus minus 4 plus minus 7 plus minus 14 plus minus 28.
Yeah.
Okay. Okay, verifying. Do you find any solution with it? Among those numbers. Hey, are you playing game there?
No.
Oh,
What's the,
positive 2 works.
Yeah, +2.
okay, it works. Okay, there is another thing called theorem. It's pretty hard to remember because you don't really use it that often. So assume fx has all the integer solution coefficients. If the coefficient change the sign d times, so from plus to minus, the minus to plus, then count as, if change is counted as 1. D times then fx will have at most d positive root. Whatever the number is, we have the same parity as d. So if d is 5, it can have at most 5 integer positive solutions, but can only be either 5, either 3, either 1. Cannot be have 4. That's the theorem saying. Probably you already forgot. Okay, let's take an example. We got this example. How many times the coefficient change?
1.
1. So it can have only at most 1 positive solution. If at most 1, it must be 1. Okay? There is nowhere to go. You get it?
Oh,
If the size change only 1, it will have exactly 1 positive solution. Okay? So 2, we already know it. So it's that's what 2 is. So for example, if you have x7 minus 2x5 plus 3x squared, x plus 6 equals 0. So that can have 1, 2, 3, 4. It can have at most 4 positive solutions. Right? But we don't know how many actually. But it can have either 4 or 2 or 0 positive solutions. So you know what I mean? You probably don't have anything at all. Okay, let's give you some trivial examples so you can see it. Like saying x squared minus x and plus minus 2x, make your life better, and plus 2 equals 0, right? So how many times change it?
twice.
2.
So how many positive solutions does one have? Huh? So it's x squared minus 2x plus 1 equals 0. So it's 1 plus minus I, that's solution. So it has 0 positive solution, okay? So even you get that change twice. All right. What is it? There you go. So we also have the complex pairs here. To assume fx has integer solution coefficient, it doesn't really have to be active. If a plus bi is a solution, then a minus bi is also a solution. So we just had an example. Actually. This example, 1 plus I is a solution, 1 minus I is a solution. It's always a pair if you use the coefficient a real number already enough. Good? Okay, so the relationship between the root and the coefficient. So the first one you have all the coefficients add up together is negative n minus 1 over n, then so they have an n relationship. The last one is x1 times x2 times xn equal a0 over n. So let's see the cubic equation. I think I have something else disappeared. Okay, cubic equation, you should especially know the cubic equation. So if you have x squared plus ax dx plus y equals 0, have x1 plus x2 plus x3 is minus a. So x1, x2 plus x1, x3 plus x2, x3 equal b. Okay, that's the cubic thing. You should remember it. So, because this is very, very important and very, very useful. All right, very useful. So the next thing is called Newton's thing. So you using the SM. So if you feel like get lost, and then you read the book. I think I get lost to something. Yeah, maybe I didn't write it. I didn't save it. Unfortunately, I closed it. The thing is, let's go back to the book. Book has it. On page 65. Oh, I see. I can see page 65. Okay, I didn't write it. Page 65. You have an s1 plus an minus 2 at the bottom of page 65. So an s2 plus an minus 1 s1 plus 2 an minus 2 equals 0 till we keep going. That's all about it's only doing couple problems, then we dismiss. Okay. I even didn't really have anything with it. Oh, I think I lost a lot of things. There is another thing we should know. I think we can save it. Another thing is about the transformation. So transformation is about if you have the fx equals to something like an xn that could be 4. So first thing, dx equals to x and then f1 over x. And this one assume that has a root. What do you call? It's called z. Okay. This one will have the root z1 over z. Okay, flip it. So if you have a dx equals to f x say plus 2, then we'll have the root z minus 2. If you have the dx equals to like say f for example 2x, we'll have the root z over 2. The basic little thing you need to know. That's all about the transformation. Okay, I think I still leave the next time we should do quick. So I actually next time probably I don't hurry. Here's the situation with them. They actually already learned to chapter 14. Or maybe we're talking about the ability to see how we go with the chapter 7 to chapter 14. Okay. Hurry, are you there? Yeah, we'll talk about how we go with that because they actually already learned those things. We'll just review with them probably very quick in the future.
Okay.
Okay.
You and me probably let's see how it does. So for today, just give you like feeling about how is the online thing going. And we using like that's only third time, I guess. Yeah, we probably using more, but I'm not certain about. We'll talk about it individually. Okay.
Okay.
So about the no matter who, and you look up the problem with chapter 6 again to see if you forgot everything or forgot anything. Like we're still doing like just to William Skyland, and we're going to do should be quicker than today because today we spent lots of time on the parabola problem, right? Okay, so we'll probably so if like anything, this video is recorded. If you're saying still confused with something, you can go back further to read about it. I think that's probably done with today. So about still the next time with William Skyland, and we're going to review quickly with the chapter 6 problem, then review quickly with chapter 7. Well, we will continue in chapter 8 very quickly because we already done one. Probably last year already. You guys remember when did we learn that?
Not quite sure.
Okay. Anyway, that's okay. That's all for today. Okay.
Okay.
Bye.
Alright. Bye.
Thanks.
Bye.